Yeah, I have also this question. It says, solve the simultaneous equation, this and this. I received it, someone sent it. It does two simultaneous equation. Hence, with the aid of a diagram, find the solution set for which the inequality. Now, so they are converting this line to this inequality. And then I think for now we can start this is an equation of a circle. And then they are turning it into this inequality are true by shading out the unwanted region. So we first do the first case. We want to solve these two. What you do, you make one the surrogate to substitute in this and simplify. So from here, so that I can easily make x the surrogate. So from here, my x is going to be, I have 1, and when I take this side, it becomes a plus. So I now put this in there. So from x squared plus y squared equaling to 25. Now where there is x, I'm going to put this in here. Be having 1 plus y the whole squared plus y squared equaling to 25. Then I think everyone knows how we expand this bracket. So this will be now 1 plus 2y plus y squared equaling to 25. Then this is going to be 2y squared plus 2y, then minus. When I bring this, it becomes negative 25 plus this one, it will be 24 equaling 0. We study something common, which is 2. We divide through by 2, get y squared plus y minus 4 equaling 0. And then we can ably factorize this out. See that? I need two numbers. I multiply, I get negative 12. When I add, I get a 1. So instead that is going to be 4 and 3 and negative 3. So y plus positive 4, then y and then negative 3. As simple as that. So see here, our y is negative 4 or our y is 3. Then y, when y is negative 4, we come from here. Our x will be 1 plus y. So from here, my x will be negative 3 when I put in 4. And here, my x will be 1 plus y. So here, my x is going to be, when I put here y, I get 4. So the coordinates going to be where they are meeting. I have when x is negative 3, this one is negative 4. So negative 3, negative 4. Then I have another one. When x is 4, y is 3. So these are the two. I think we see it's a quadratic. In terms of x, we expect two values of x, this and this, and so two values of y. That's why I also have this and that there. So those are the two values we have. Now, so we have solved those two simultaneous equations, having those values by now. I need the points because I'm going to plot them. It means that now, first of all, this line here, you see this is a linear equation. It's passing through these 2 points. So it means I come and I plot those 2 points. First of all, I have negative 3, negative 4. Negative 3, negative 4 is somewhere there. This negative 3, negative 4, somewhere here. So that is the point. Then I have also 4, 3. 4, 3 is somewhere here. I think you can able see that somewhere there. So that is the point. So that's going to be 4, 3. Here this one is going to be this one here. You've seen it's going to be negative 4, negative. Sorry. It's going to be negative 3, negative 4. So negative 3, the x, then negative 4. This is this point. Then now, we need to draw this circle. So when I come to this circle, you know it's x squared plus y squared equaling to r squared. The general equation of a circle centered at 0, 0, with the center at 0, 0. So if you compare with this one we have here, so that we have x squared plus y squared equaling to 5 squared. From there, start our radius is going to be 5 units. So the center is going to be at 0, 0. This is the standard sum. Center 0, 0, then this is the radius. So you see this is 25, which I can write as 5 squared. Then, so now this is going to be my center at 0, 0. Then radius is 5, it's going to pass there, it's going to pass there. From here I count 5 units. Because from the center, I've decided I count 5 units. It's going to drop there. From the center, 5 units are there. 1, 2, 3, 4, 5. Then here, 1, 2, 3, 4, 5. So now, you can get your compass to show you. But now here, we base on the side. You see, because this one is that our inequality is x squared plus y squared less than 25. So this one we use dotted lines or dotted. So this one is going to be dotted or dotted. Then this one, when we have for x minus y, it was greater or equal to 1. Here we use solid lines for inequalities. This one is just broken, and then this one is solid. Because of the inequality sign of the sign, whenever it's greater than or equal to and less than or equal to, for them we use solid lines or solid sum. So this one here, because this one is less than, we are going to use now a broken sum there. So you can put here and then you point out your 5 units. So these are my 5 units, like that. So that's where my sum is going to pass for, because just the sketch, as you see there. It's going to pass there like this, then it comes like that. So from here, you can put mine here. So if I put mine here. So I can going to try to draw using dotted lines like that. Those are my dotted lines. Dotted lines. Sorry, that's that place. And they are dotted lines, as you can able to see. Dotted lines. Why am I using dotted lines this time? Because I'm drawing now a circle. So I can come and then maybe make them thicker a bit. So instead of passing through 5 minutes, comes this side like that. You see it's passing through this point. Passes there, and also comes this side like that. So that is my circle I'm drawing. I think you see it's passing through there. Then it completes there like that. So that's the radius. It has radius of 5 units. This is 5 negative 3, and this is our 4. Negative 3, 4. This is our 4, 3. But remember, we have this. So now I draw this line. But remember this line for it, the case for this line, when it's going to be solid, the line is going to be solid. So I draw it like that, then like that. So that is now my solid line there. So now, remember when we are drawing inequalities, we have to test. So, testing. I'm going to test now x minus y, this inequality greater or equal to 1. So, you know, this inequality, if it's a line, it means that it's dividing this into 2, the upper and then the lower. So you choose any point either up or below. So when I choose a point here, you see this point here is 1, 1. Or you can take 2, 1, it's up to you. So using a point, now we are going to test using a point 2, 1. Sorry? is that point, this point I'm taking 1, 2. That point 1, 2. If I take 1, 2, so it's point 1, 2. So this is the x, this is the 1. You see, it's above the line. So when I put it here, 1 minus 2. This side I have 1, so this is going to give me negative 1, which is less than 1. I think you can see this. So meaning, where I got this point is unwanted. So I got that point, so I hold it up. So that means that that's going to be unwanted. So I shade it up. Because I got this side, but you see it's not corresponding. This is very good, this is just less. So because it's contradicting with this side, it means that now I'm going to shade where I got this point from. So that's why above. So that's why I'm going to shade this side. So I shade like this. This is the unwanted. Now the unwanted is the other side of the line where that point was from. So this is now the unwanted. Now, for the case of the circle, remember our circle is x squared plus y squared greater than 25. Is it greater? Less than 25. So now, for the case of the circle, still is just using a point. Now, you see here, the point I have is, now for a circle, we have two regions. The inside region and then the outside region. Or the region below the radius, within the radius, and region outside the radius of the circle. So we have the inside region and then the inside region. So for that, we test either you pick a point inside the circle or outside the circle. So outside the circle here, you can take this point is negative 4, 6, or you can take one inside n. So when I take one inside, I can take 1, 1. So if I take a point 1, 1, you see 1 squared, I have 1 plus 1, 25. So this is 2, but this 2 is less than 25. So see that this one is satisfying. You see this is corresponding with this less. So when we got this point from, it means that that region is satisfying that condition we have there. So it means that now I got it inside within the radius. So meaning the inside is wanted. So the outside now becomes unwanted. So that's why now I'm shading outside above that radius. So that's why I'm shading it like this. Outside, because that's where I never got that point that side. So that's why I'm shading like this. So this is the outside. So now I think you can see this is going to be our wanted region. So shading now the unwanted region. So now this one becomes the wanted region only because this one is unwanted based on the line. This one is also unwanted. Though this region is all wanted based on the circle, but this region above this line here is unwanted. So the region is wanted is this one here. This one becomes our wanted region. So wanted region. Now here you can get the solution set for that. There are many points you can pick. So you see these are the points, all these points are going to satisfy the set of these two inequalities there. All the points falling in this region. You can see 1, 3, 4, 1. Then you come, you can pick here 1, negative 1, 1, negative 2, 2, negative 3. Here you have these sets of points here are satisfying those two inequalities. So that's how we handle that question. It's as simple as that. I wish you well. Please don't forget to subscribe to the channel. We have seen these such inequalities in the complex numbers. It's also there, but this one was basically, I was doing it in terms of inequalities. See you there. I have added for you at this point is in the wanted region. This point here was in the unwanted region based on the conclusion because it was contradicting this side. This is wanted because it was and subscribe to the channel. Okay.